All right, so I've got a few questions coming out about how our setup is. So this hole was our old bathroom fan, which is just off of our hallway, and in our foyer of our house, we have a wood stove that we heat our house with. The basement gets cold, but what this does is I have a fan, inline fan in the floor system that is piping the hot air over into the basement. So it pulls in from upstairs. And typically this area up here, when the main thermostat's running about 21, 22, in the hallway, the roof area is 23 to 24, but sometimes when we really cook the fire up, we'll hit like 24, 25 degrees in the hallway. So this is getting some seriously hot air, because what we're going to be doing is actually moving this air intake, re-drywalling this and putting the air intake up here nice and high. And then that will just move air from upstairs to downstairs, because the house system isn't enough. Now this is the air intake for the hot water tank specifically. It pulls air in from the same hallway. Obviously it's right across from each other. And these two fans being at this end actually help pull hot air down this hallway, because this is a one level on this part of the house and the other is a two-story. So yeah, this is the air vent that directly pulls down into the hot water tank, which I showed in some other videos, but I'll retouch on those. I'm going to join these videos all together. The thing that I did with the, this is the midpoint between the fireplace to our left and the bathroom to the right, and that air vent for the hot water tank. I'm pretty private, so I don't show my house. I'm going to do snippets all together. But I'm willing to help other folks out get figured. So this sensor, it was supposed to be mounted outside to measure the outside temperature. So we could just, have that. We have multiple temperature sensors all through our coop and a whole bunch of different stuff. But they had it just outside the furnace when they installed the new furnace 10 years ago, and they had the temperature sensor right up very, very close to the return piping ductwork, and it wasn't even outside. So they did a poor job. That was A+ plumbing in St. Albert. I believe it was A+. Yeah, so nice guys, but they didn't do a very sufficient job of working it. So what I did is I moved that temperature sensor to the outlet on the heat pump. And so that's actually reading what it's pushing the air out to outside. And so now I know how it's operating, and if it's running consistently, it'll fire up. So it's actually cooling it off, because the basement's about, in that room, it's about 15, 16 degrees right now, and we're 21.5 up here because of the fire, because right now we're actually set at 20.54 to maintain heat at night. I had it at 19, but that's just damn cold. I don't like 19 in the morning. I'm not a big sweater wearing person. There, just went up again. So the fire's doing its job. And if I ran a temperature gun, of course the air intake would read 23 to 24 just for heat rise. Upstairs it's like 27, 28 degrees. So our children get a little warm. So they have fans in each bedroom and they run constant moving air. So yeah, and then something else we do is we run our furnace on constant fan on low speed, just to be moving air all the time. So we're pulling that cold air up and moving that hot air around as much as we can. We've done it where we don't do that. We run it at medium. We don't run it at high. It pulls 450 watts constant. This fan actually only draws 130 watts due to my energy meter, which is great. It keeps it fairly low, and it's just a well-balanced house because we're always moving the air. And yeah, it kicks on through the night, and our power bill dropped $170 since we've been running wood on the gas side. Not the power, but the gas side. Electricity, of course, has gone up, but we're working on a solar build, so we'll have excess energy during the day, so we'll superheat. I got other plans. I'll be going through videos on that for sand batteries and solar storage and thermal storage and all types of stuff. All right, so this is our wood stove, which we had installed. Honestly, I could have done it myself, because yeah, it's actually quite easy. And then add a wet certification done on it. We run a big 60-inch fan because this is the second story of our house, and that fan really moves that air back down because it gets captured up in the upstairs section. And yeah, we run this wood stove all the time. We have 2 temperature sensors on it to make sure we're maintaining that we don't go over, you know, when this hits 500 on the container, because we're on the grid, the actual belly is probably 550, which is too hot. So you start to get a bit of a smell. When this guy gets up to, this is B pipe, so you got the extra wall of insulation. When it hits about 450, you start to get a little bit of the smell coming off the pipes. And that, of course, is the external temperature. So the internal temperature of those pipes, yeah, it's probably up in the 500. So that's a real cooking hot system, but it heats up really nice. So yeah, I can probably post the name of it, but whichever. This is designed to heat about a 2,500 square foot space, and it has done awesome. Now we have a property where we provide our own wood, and we sweep our own chimneys twice a year. And of course, in the summertime, we don't run it at all. We typically run AC maybe 10 to 15 times a year. It's not very often, just when we get the big 30-degree+ days. People would ask, you know, with the furnace blowing out air outside, is you would be pulling your internal air, sucking on your internal air. So this system is actually designed, I can't really show it. Now, there's a connection on the bottom that I could direct air straight into the stove. But what I did instead is, nearby the wood stove, is I have these grids cut in under my, just my little platform stairs here. And there's a pipe work, 5-inch pipe that runs down in the floorboards and out to outside to pull fresh air in specifically for the fireplace, so that we're making sure we're getting our return air, so we're not, you know, becoming a negative pressure home. Yeah, there's cool air, and we're at -28 outside right now, and there's cool air coming in, but it pulls it in, the fire burns it, it's great. We could have vented it directly to it, and then the fire would be self-contained and we wouldn't be pulling air out of the house at all. Oh, look at that, I mean, that's disgusting. We have cats. We didn't want to do that because I wanted to make sure my house had the ability to draw air, and if ever the wood stove's not burning, the house has another input point to draw air in, and we don't want that cold air dropping straight down. So what we do is we just put this plastic shield on here and set it in place like that. Can't even really see it, don't even notice it anymore. And what this does is it just gives us, keeps the cold air on the upstairs side, keeps it from going down into the downstairs immediately, because it was making this first area down the stairs here really, really cold. So yeah, this just gave us a little barrier to keep the air near the fire stove. So this is the bottom of that air intake for the wood stove, and basically it's 5-inch ducting, just runs straight over. And oh, sorry, this is in my gym. So we insulated it nice and far back so we don't get any condensation. I was learning how to do all this stuff, and I messed it up a little bit, so we had a little bit of condensate buildup and freezing right around the thing. Didn't do any insulation, and we had finally just went and put a rock wool insulation in our cubbies, because that was a major loss for the energy guide. We had a guy come out and do the pressure test and all that, where we're losing our heat with this thermal sensor. Huge difference. Get it done. We were here we've been living in this place for over a decade, and we didn't do that right away, and they of course didn't do it before, and it was like cold. So that cold just kept this basement. It went up about 2 degrees in the basement by doing just that insulation and that. And so yeah, so insulating, make sure, seal it, tape it, all that stuff. You know, the beauty about insulation, guys will lose their mind and tell me I'm gonna have to destroy my house, but the rock wool doesn't get affected by condensation, which is super awesome. So we don't have any plastic ceiling and all that stuff outside, inside, because it doesn't condensate. We have killer cold temperature outside right now, and there is not an ounce of condensation buildup. I can pull that rock wool away from the wall and there's no condensation there. So they're all saying, you gotta seal it and goop it and all that stuff. Yeah, well, we didn't. And we're not having any issues of what anyone is talking about. And again, we've gone through -36, -28, -22, high humidity at 83% at -27. And then we've had the basement to 20 degrees, 15 degrees, 18 degrees, all over the place. And we're not having any condensation issues, except on that pipe. We were having some issues there on another pipe where I was learning ductwork. So yeah, this is definitely a do-it-yourselfer. And again, I said I'm pretty private, and I don't need people to tell me what I can and can't do, but I will research the hell out of it to get it figured out. So and if I do it wrong, well, that's on me, and I'll make it right. Electricity, a little different deal, because that would kill you. All right, so this tip cutout here is we're not done in this room. This is actually our theater. I can show you a little bit of that. It's painted wall. We used multiple different colors, and we just painted the wall. We've got to do a better job on the mudding to make it just a little less grainy. We're only running 1080p right now, but when we move up to 4K, that grain will show up dynamically. At certain images on certain colors, you can see the grain coming off the wall, and our mudding is a little bit off. We're still learning how to do that. My wife's the mudder, and she's very good. I suck at it, so I don't do it. But we ran the certified speaker cable routed out in behind our trim, built all that ourselves to the center speaker, and painted up the trim in here, routed it out so the speaker wire comes out here nice. Run it all through, and this is actually just landscape fabric presently, because we got potentially more plumbing to do, and I'm not going to be throwing up a roof or drywall and have to rip it down until we know we're 100% done. So I had cut a hole in here to transfer some of the hot air down into the basement, because it only right now is 14 degrees down here on minus 27 degree outside day. So but what I did is I wanted more temperature for the hot water tank on the other side of the wall, so I ended up piping it over. And that fan body's right here. That comes up from the bathroom upstairs, and that inline fan, I don't know who made it. It's one of the standard ones. It's just moving air, and I have it turned down to low right now. If I wanted to, I could crank this baby up. And that gets pretty loud. Like, definitely pretty loud. It's irritating upstairs. It's irritating down here. But on low setting, it's pulling 46 decibels at not about that far away, 5 feet. So yeah, we have electric heater if we want for movies down here, stereo projector, yay. We found a few theater chairs, and yeah, always wanted our own theater, so we made our own theater. So fun little tidbit, what we like to do, and some of our enjoyment stuff. But yeah, so I'll go to the other side where the hot water tank is. All right, back to my my heat pump build, as I've got more videos. I'm going to joining these all together. So the previous video is kind of a big repeat. This is the piping coming from the hallway that I had mentioned before, but this time I actually got a short video of where it's coming from, and that brings it down here. Again, we're going to build a proper air intake port for this. We're just keeping that cardboard box held down by a little box that has some weight. Yeah, it works awesome. So that's pulling from upstairs at that nice warm 23, 24 degree air. And then over there's that air tube up there. Again, very shoddy work right now. We're just doing a bunch of testing. It's blowing the bathroom air that we're pulling in. So yes, if somebody uses the washroom, it's going to be blowing that stink air downstairs. It's not a high humidity bathroom, it's just a toilet and sink. So you're not moving humidity downstairs, which our house runs a little drier anyway because we're a wood foundation. But yeah, so anyway, that's what that is, and that's just moving that air into this area. Now, I had a question about, I have it set to 130, 140. What's my power usage? How long does it run? You can probably see that post with AV, I believe is the user's name. And yeah, so we run it high. The reason I run it high is we have a family of 5. There's 3 boys, adult males, my wife and myself. And by running it at a higher temperature, one, you keep Legionnaires down. We are on a well, so I believe Legionnaires, bacteria or disease, whatever it is, 140 kills it. So that's a minor concern for us because our well water is actually really, really good. But we wanted a large amount. So basically, we don't have a after valve, mixing valve. The mixing valve is in control of your hand when you open your sink. Just don't turn the hot inside. Yes, you could scald yourself if you keep your hand in there for a minute and a half. You're going to burn your skin. Most people pull their hand back when they feel heat. So you teach your kids how to be sensible. So we run at higher temperatures, so we use less hot water when we're doing a shower, and we just use more cold water because we're just, mixing. Typically, we go straight up on any one of our sink valves, and that mixes it all together real nice that way, and we have a lot of hot water because of that. Now, I can't remember the last video, I unwrapped all the insulation off of this because this was condensating when it was wrapped up. So that was no good. So we ended up wrapping it to this point, and it's flex up to here. We have it join into rigid under here, and that rigid, yeah, I did all this. Anyway, rigid goes all the way outside. And then I have my butterfly actually mounted outside the wall. So I can see if it's condensating, how it's doing, if it's opening and closing, and it's working awesome. Absolutely fantastic. So I'm not getting any backdraft of cold air, because a day like today would literally shut off my heat pump from kicking on because it would be just too cold. Yeah, and then it's a nightmare to get going because I got to open this up and blow hot air in there with a heat gun to warm up the thermal sensor switch inside here, that it detects that it's too cold and it won't let the heat pump fire on, but it doesn't tell you. So Rheem really has messed up if it's the whatever the monitor company is. There's two different divisions on this, so you can't call Rheem and ask questions about the programmer. You have to call whatever the company is, like, I don't know, and they don't really know the Rheem product. It's really irritating, so they kind of screwed up there. I know A.O. Smith makes a nice heat pump system. They may be a little bit more balanced. So as a company, I'm impressed with how it heats. I mean, the two electrics turn on and the heat pump turns on. You can fill a bathtub, and we have a 120 gallon bathtub. It's a big boy. It's like, I'm 6'2", 3. I can lay down in that thing and my shoulders are out. So it's awesome. And it'll fill that puppy up. It's not one of your tiny little toy tubs that most places have. So, so as a product, Rheem is quite impressive. I'm quite satisfied with it. As programming, it's lame. It's totally horrible. The app doesn't tell you anything. You don't know what's happening in your device. I had a couple of alerts that it couldn't keep up with the call for demand. So you can go through and you can clear them. Like you go in there, alarm beep, sure, yeah, beep at me when something's not right, which is great. Temperature, and that's another thing, the alarm beep. It'll beep on here, but it won't tell my app on the phone, which is connected to the Wi-Fi channel, that there's an alarm issue. It'll mark it as an alarm, but it won't tell me. So it doesn't really help me jump to it. Current alarms, there's no alarms. You got 4 there. Alarm history, nothing there. But when it does, you would see like T132, which is water heater unable to sustain call demand. You can then just go next again. If you want to clear it, you hit clear. I hit clear twice, enter twice, and then that history's cleared to see what comes up next. Network, everything's good. Shut-off valve installed. Again, the shut-off valve is this guy down here. So if I get a leak, it'll detect it. It'll shut the intake line so this doesn't get any new water, and then really you're only getting backflow. If there's air open up on your pipes, then that backflow could have your tank drain down, but you're not going to be running your well forever dumping water into your house. And that's it. So that's really it. There's nothing else. There's no sensor data, nothing. The older model that was sideways and had like a different panel, same shape here, but a different panel here. It had more information. It was a better programming. What other questions? If you run it at 110, that was a question Avy was asking. 110, yeah, you're going to run it a lot less because you're just not heating trying to heat as far, and depending on your water intake temperature, like we're on a 300-foot deep well, we're getting quite a dynamic amount of cold water coming in, so it has a big range to heat that up. Again, that's why we run it to this point, because we want to have a lot of hot demand for the nights after, you know, all the sports and stuff. So if you run 110, which I did for a while, it did really good. At 120, it did really good. 140 does really good. You use more energy, you got to heat it more, you're going to use more energy. Again, I am building a solar build. I'll move over to that here. Oopsies. And that solar build is going to be, you know, big old system. It's going to be a 25.5 kilowatt system. So on a good day in the winter, we're going to be able to create over 200 kilowatts in a day. That's a lot of power. And my batteries are 45 kilowatt. That's, you know, easily charge those up. The charge controller can output 100 amps of charge. I'll have 3 of them. so they can easily charge up the batteries and power my house. Our usage is high. We use 2,000 to 2,500 watts an hour. I'm running the full Schneider. I'm going to have 2 XW Pros running my off-grid, and then I'll have 1 XW Pro feeding back to the grid, and then they'll also be my backup. So then I can pull power from them to, if for whatever reason my off-grid isn't keeping up, if the sun is low, I can pull power to pump up my batteries from them. These things are amazing. Nothing's wired up yet on this system, so. And we're going to have a solar shed and all that jazz. Lots of versatility. If you're looking at this stuff, I'd be happy to go over with individual questions on solar. I'll be doing videos more on this stuff as well. It's a complex system. I am building it myself. I do have an electrician working with me on it. And then I also have, sorry, moving a huge 600-pound battery here, a engineer tech working with me on that as well for signal line, all that, and working with the Fortis company. So here's a little look at the big batteries, 15 kilowatt batteries. These are all parallel together right now, so they're balancing, and you got good control of discharge, charge control, so they're not charging, of course. I don't allow power to come in because there's nothing coming anyway. Altogether, these three give me 900 amp hours. Yeah, the BMS on this system's good. It's impressive. It does a good job, and I have them parallel so they maintain temperature better, and they're just in sleep mode because nothing's happening. But I wanted to make sure they're charged up. These will be in a solar shed as well, and then yeah, upgrading my off-grid panel will be this Square D 200 amp panel. You know, here's the other equipment. So this guy, it's a beast. It's 40 circuit, 40 whatever they're called, connection points, 80 circuit. And then there's my old one. It's a disaster. Yes, everyone knows, don't touch it, stay away from it. And I think I shared this as well. I use the View energy monitor, which is great. It's a fantastic little system. Yeah, a lot of ports on here. You can, you know, mark out which ones go where. If I can figure it out, I'll get some videos from how it shares the data and how it pulls. There's 2 big, huge current CTs inside on the 2 line 1 and line 2 of the grid coming in. That reads up to 200 amps, so they're fantastic. I can see the whole house. So yeah, this is, of course, it's an open system. You don't put your hands near it. And one more thing with the decibel rating, it's not turning on right now, so it's not calling for demand, so I can't do a decibel test, but I believe it was like just the heat pump. Of course, electric's totally quiet, you hear it click, but yeah, when the heat pump runs, it was 50, 52, 55, 56, somewhere in there. Not excessively loud. I can talk at this level right beside it right here, and you know, barely raise your voice. It's not that loud. Now our bedroom is right above this, so sorry, our bathroom of our ensuite is right above it. Now I can hear a kind of like a little bit of a bzzz sound. It's not intrusive. You don't really notice it. There's no rumble at all. Again, running flex, I'm not contacting any surface in any major fashion, so I'm not transferring any of that noise, vibration noise, into the house body. So yeah, decibel wise, it's great. And how long does it run? I'm going to try to share the View energy monitor specs. Now again, I've been running my system hotter, so it's not as accurate. You'll use way less power. You'll run way shorter running at 110, especially if you have a warmer intake source. If you run city water, it's not coming in at, you know, 7 degrees. It's probably coming in at, you know, 15 to 20, 25, whatever. I don't know, whatever your cold temperature is. I haven't been in the city forever. So, yeah, decibels, I think that was the other question, and how long it runs. Again, I've been testing like mad, so our system's been all over. My energy usage is super high and super low. Today, it's already at 6.5, 7, and we're at like noon. But last night, you know, I had a shower at 12:30, so then it had to reheat itself and run up to, I could have left it low if I scheduled it to not heat until day, which I'm going to do once I have my solar up and running. But right now I don't care if it draws from grid tonight or day. I'm going to have it, supercharge the temperatures while I have solar to utilize thermal storage. And then at nighttime, we're going to, get everyone to work on having showers a little bit earlier in the day, so we're not drawing on the batteries overnight when it's not monitored for the first bunch of time. And yeah, so I hope that answers that as well. I don't think I have any other questions in my posts. Emporia Gen 2 view module, and that's the one that's attached to my electrical panel. It has 16 circuits of 50 amp. I don't know what they're called. They're called CTs. I don't know the breakdown of what that means. Circuit transformer. No, I don't know. Whatever. So it has 16 50 amps capable circuits. So those are pretty cool. Now, when you have 40 channels or 40 circuits in your house, you gotta swap them around. And you saw my disaster on my panel. They when they installed them, they didn't go direct. Some guys like come in and go almost directly into their circuit. These guys, whoever did it, left like 16 inches or 18 inches of each line looping down over top. It's really hard to reach in and pull out and clip onto the one line that you want. You can clip on the black or the red, but you can only clamp them over one of the wires. If there's two wires inside, like a 14-2 conduit, you can't clip over both. You have to clip over. I had to learn that because I was like, it's not reading, what the hell? And it's because you can only choose one wire. So not an electrician by trade. All this is learning. But what's really awesome as well is it has a 200 amp CTs. Now the 200 amp is on my main circuit. So this is pretty awesome. So right now I'm in home. I think I have it set so you guys can see my mouse. So while you're in home, you can see everything that's on. And then if you want to see your total usage, when you click on that total usage, right now I'm pulling 5,100 watts per second, which is fantastic. If you want to scroll, click the screen, grab it, drag it across. It's also an iPhone app or Android app. This is on my computer itself. You can log in. So it's pretty cool. Minutes, I can show you how many minutes you've been pulling. So reason I'm pulling so much power is we run a hot tub, and we also have the hybrid hot water tank. I went way too far. That just jumps really quick. That's irritating. There we go. So I'm pulling up to 8,500 watts in this time frame. So what this would be is in that time frame is at 9:35 p.m. all the way till, I bet it's about 9:46, 9:47. Okay, so the hot tub turned on. It pulls 5,500 watts just to run the heating circuit. And we're at minus, I don't know, 10 degrees Celsius right now in my area. So 5,500 minus 85, that's 3,000 watts. Now let's look over here. Yeah, 3,900. So we're pulling pretty firm. So that would tell me that my hot water tank is running in that time frame, and that was at. So I clicked on hot water tank. What did I say? 9. Ooh, too far. Go back. So my hot water tank wasn't on right here. 9. I kicked on at 9 something. There it is. So it kicked on. It was running the hybrid pump, the heat pump at this time, right here. And oh, something else is pulling 3,000 watts. So it's running heat pump only, which is great because the app for the EcoNet, it's okay. I know I've complained about it a bunch. I don't want to be too hard on them, but they're learning how to make it better, I hope. It doesn't really show the energy usage in the hybrid heat pump itself very well at all. So I've been using, 3 different devices to measure everything. My Bryant furnace that we had updated 10 years ago, they had that thermal sensor wire that I showed you guys on the video. I have that tucked in behind the output reducer, and it measures the temperature of that output. Instead of measuring the temperature of the intake going to the furnace, I don't really care what it is because it was tucked right in by my furnace that should have been outside, and they didn't do that. So
So I moved it over to my hot water tank, and we really don't run gas much at all, only through the late hours of the morning, like 3 a.m., 4 a.m. till 8 or 9, because we run the wood stove. And we load it up at night, crank her down, about half throttle, 60% choke, and it just purrs along and keeps us warm through the night. And we have a fairly large house, 1,600 square foot on the main. And then a second story on about half that. So the heat really travels up right away. It's in the foyer. So then we have a big fan, which I showed you guys on the videos, and then it pushes the air around the house. So our end gets a little cool, but we sleep well in cool air, so it doesn't matter. Anyway, I can ramble, I apologize, but like I said, I'm not a pro YouTuber. This is the heat pump over the hourly basis. So today is a great day. It really didn't run a lot. As you can see, there's all these empty zones where it didn't run at all. Here's a big draw. Let's get back to that one. What does that jump up to? Was that it? There it is. It goes very quick when scrolling with this. 4.4 kilowatts. So at 11 p.m. Oh, yeah, that was my shower. I believe that was my shower there, somewhere in that time frame. And it kicked on and ran. It pumped in the electrics. Now I'm on high demand mode instead of energy efficient mode. And energy efficient mode is good, of course, but I don't find it doesn't kick on the electrics soon enough. They also don't tell us what type of delta there is. If I have it set at 140, is the delta 20 degrees and it'll kick on the electrics if we're still drying and it hits 120? And it'll turn the heat pump on when it has 135, a 5-degree delta. I don't know. That delta is the distance, the difference before something would be activated. Now, in high demand, I have to assume, there's no literature on any of this, I have to assume that the delta is closer than the efficiency mode. But again, I'm just trying to learn from using an energy app to see what it says. So yeah, it's kind of do your best with what you got. Anyway, I'm trying to focus on the Emporia Energy app here. So the graphs, we're in graph mode right now. I can go to my daily, and this has been just a godsend for understanding what's coming. So today is a ridiculously low day. I don't know what's going on, but this is awesome. 1.99 kilowatts. Nobody's had a shower today. There was no sports today. And yesterday, all right, 11.4. It ran a little harder. Day before, 15.4. So it's all over. It can really drink a lot of energy. The heat pumps are fantastic. I like them. They are very efficient. So if we look at a big day here, okay, 16.2. Now my pricing is, I believe, 13 cents with all the taxes and all that stuff on there in our area. All right, so $1.30 for 10 kilowatts and 6 is 60 and 18, 78, $1.07, $2.08 for that day to run our hot water. Now again, as I've stated, I'm firing up a solar system, so we're going to supercharge it. Run it into super high heat, and then turn it down in the nighttime. And then have it when solar comes up, it'll power up that heat again in the day. So here's a weekly. You can see what's going on here. We're all the way back into December. It won't let me scroll back nicely, so I'm gonna not scroll. Estimation on this day, yeah, okay, 55, 60 for that week. Down here, way up here. I think back here, no, we installed it then. Yeah, these points over here I had that circuit on a different channel. We installed it in the middle of December. So this was that, and it pulled the first day, pulled 19 kilowatts just on one day, just to heat it from our well temperature, which I haven't tested my well temperature. I really don't care. It is what it is. All the way up to 120. And then here I was fooling around, playing with different things, tried full electric mode for a week. And so these aren't real numbers because I've been messing with it. These last 2 weeks are probably pretty accurate. Unfortunately, you can't click on it and see what it is. It's kind of bad that way. I guess I can scroll over one bar. Come on, scroll. No, there it is. 57.6 in that week, 47.9 in this week. We still have tomorrow to finish, which will be Sunday. So that's awesome. Monthly usage. Okay, great. Let's get off this. Let's get off that circuit. Let's go back to total usage. So we're on monthly for my house. So we're 1,717 kilowatts, 1943, 1948. I've been running this Emporia since last November of 2021. So there's a year. In here, this is not right. I had this system shut off. I think it was doing some electrical or something. So what didn't read the proper year, proper usage for that month. And I should say one more time. Yeah, that's great. Yearly usage. There we go. 16,709. That's a lot of energy. And now we have the heat pump in there, and its additional draw is going to probably push us up to 18,800. So that, yeah, we're going to be allowed to send back a lot of power. I am connected to grid. I will be connected to grid, like I said, with one inverter, and then 2 will be ground mount. Will be off grid for our house. And the off grids will really be running off grid most of the time. We don't plan on pulling from the grid. It will be backup to recharge our batteries if we don't make it through a night or something like that. So it's going to be interesting. We got 1 or 2 years where we couldn't essentially not pull any power from the grid at all, and they Fortis up here lets you send back your previous year or 2 worth of power, and if we don't pull it all, which I think we will, that would get us to be able to stay on the system where we can send power, because you can't be a revenue producer yet. It's kind of crazy. We have all this clean energy. I'm going to be able to create 200 kilowatts a day on a really killer awesome day, and down to 2 kilowatts. So if it's a 2 kilowatt day, it's going to suck. I'm not going to recharge my battery. So you have to have a generator or a grid for backup. So I'm not interested in doing the grid too much. Generator too much yet. I have one, big 8,000 kilowatt. It's manual start. I could wire it in to become an auto start. Then add in a AGS automatic generator start module onto the Snyder build, and then that would go. So anyway, I'm going into solar. That's a whole nother world. Management in this program. You got time of use, peak demand management, excess solar management. So once the solar's hooked up, this will know. I'll be able to tell it. It's pretty cool. And then right now I have it disabled, so I'm not going to muck around with it. Notifications, manage devices. This is pretty cool, so I can manage the entire circuit. So you can go in and name your circuits, whatever you want to be watching. I found that just simply naming them is not that great, because circuit 8 on the module itself is okay, great. It's plugged into the 8th port on the Emporia, but I don't know what breaker's on. So then I got to look at my panel. It's just a waste of time. So I learned to now go, okay, my furnace is on breaker 36. Now I know I can go to that circuit, and if you want to change it, you can go in and swap up the names, watch out the breaker, all that stuff. And of course, you can also choose what it is specifically. And so yeah, it's good. It's great. If you have a 240 volt system, but you don't want to run 2 CTs on one on the red and one on the black, you can add a multiplier. So that comes in really good on the hot water tank. There it is, right here. So I just went 2 times on the multiplier for, I have the CT on the black, I think, or the red, whatever, doesn't matter. And yeah, I just put a multiplier of 2, and then it doubles that. What would be interesting, I haven't done this yet, is putting a CT on each, the red and the black, and then have it labeled as line 1 hot water tank, line 2 hot water tank, to watch for imbalances in the flow. So that's something interesting. Unfortunately, the home circuit doesn't do that, which I wish it did, because I actually have, it just shows your total usage, right? And that's not overly helpful, because I can't see direct imbalance. Why am I still pulling 5,000 volts? I don't know what's running right now. Hot water tank's not doing it. Oh, my son is running a 3D printer. Yeah, this is kind of interesting. It really helps you break stuff down. We're schoolroom. Sorry for the slow delay on all this stuff. Schoolroom's not on here. What the hell? There. No, that's not pulling any power. 63. What is this? Yeah. No, I don't know what it is. Something pulling power in the house, and I gotta source it out because that's a lot of snot going out of the house right now. 4,500 watts. Anyway, this is how it works. You kind of fight to source things out. So I have a circuit off of something that's big in the house. But yeah, you just, if you had all your wires accessible, you just clamp the CT on that circuit and you can see what's pulling big power. And away you go. My other son is in the garage. Maybe he's pulling some power, but I took my garage circuit off because it was pulling like 0.31 amps. Notifications to show. We did management. We did graphs. That's really it. It's pretty impressive. If you go into their smart plugs, you can literally control their circuits through like a thermostat. If you get their thermostat, you can control it through this app. Smart plugs, you can tell it to turn on or turn off. They're $30 each, 35. You can get a pack of 3 for like $80, $70. It's pretty cool. EV chargers, they got batteries. It's pretty impressive. So they're coming soon. I have another web page open, but there to look at their batteries. Saw a little bit of information. They're not the best altogether, but I like the big battery and I like SOK batteries personally. You can set different how you want to see your measurements, how many trees you're saving, how much carbon you're putting out. You know, if you're not putting carbon into the atmosphere, your trees aren't breathing. So I have some mixed views on carbon. Although I am a very energy efficient person, I like to, I like clean air, but I kind of disagree with a lot of the propaganda about the carbon emissions and global warming and all that stuff. Whole other topic of discussion. Look at sunspots. There's spots that cover this section of the sun for a short period of time, and they reduce our solar irradiation that we're getting on Earth. And there's cycles of it. There's 400-year highs and lows. There's 100-year highs and lows. There's a cycle every 11 years. There's a lot of stuff. So, sorry, I'm going off to a conspiracy guy here. Pretty cool. You can watch your amperage. That's not bad to have. There we go. I didn't see this before. There's my total usage on A and my total usage on B. So my B channel is pulling heavy right now. Something in B channel is, I did not hit that. Yeah, I did. 42.7 amps at the second. So I'm a little bit unbalanced. That's awesome. I never saw that. So learning all the time. Don't ever feel afraid to be lost on what you're doing and just click and play and keep it safe. So again, guys, I make long videos, and now I gotta figure out how to stop this recording. I don't know how to do that. Cool. All right, have a good one.